Assalamu alaikum to everyone. This is Tahveer Yusuf here. I welcome you in my YouTube channel, and today I'm going to take the chapter 8, that is limits and derivatives, from Math 1B first year. As you can see here, limits and the derivatives. The limits, this is the most important part in the calculus. Let's take an example to understand the limits. I will write f of x equals to x plus 3. So this is a function x plus 3. It is same. It is nothing but same what you have studied in your previous class. If we have the variable like polynomial p of x equals to x plus 3, I'm asking you find the value of p of x when x equals to 1. What you will do, you will substitute the value of x here. So you will get p of 1 equals to 1 plus 3, that is 4. If I will ask you find the value when x is equal to 4, what you will do, you will write p of 4 and in place of x you will substitute 4, then plus 3 is there, that is 7. So you can say that the value of the px at x equal to 1 is 4 and the value of px at x equal to 4 is 7. What is actually? It's nothing, we are substituting the value of x here. This you have studied in your previous classes. And similarly we have a function fx equal to x plus 3. That means for every input value we have the value of the function. If I will ask you what is the value of the function at x equal to 3, you will write 3 plus 3 equal to 6. If I will ask you what is the value of function at x equal to 0, you will write f of 0, in place of x you will put 0, that is only the 3. If I will ask you what is the value of x, what is the value of fx function at x equal to 10, simply you will place here 10. 10 plus 3 is 13. So it's very easy. Now coming to the limits, what is actually the limit? How we are writing? First we will understand what is the notation for the limit. That's notation. How we are writing the limit? We are writing simply limit LT x tends to 0, or x, here will be one value, here be the other value, here will be other value. Sometimes here it will be infinity, sometimes any real value will be there. X is tending to some value, and it is also written as lim, x is tending to 0. Now how it is read, how we can read it? It is very common, very simple. I can say limit x tends to 0. It is read as x tends to 0. We can read it limit x is tending to 0. We can read it limit x is approaching to 0. We can read it x limit x is x approaches to 0. Limit here limit. So the way how we can read it is limit x tends to 0. LT we can write, LT stands for the limit and LIM stands for the limit. Limit x is tending to 0, limit x is tending to 0, x is approaching to 0. These you should understand. Sometimes we have like limit x is tending to infinity f of x. Sometimes we have limit x is tending to any value like 4 f of x. So what does it mean? We will understand what does it reflect. It means tell the value of the function when when some input is approaching to some value. It is asking us the value of the function. So limit is the value of the function when some input is approaching to some value. So from here we can say the limit is the value of the function fx when the input x is approaching to infinity. And from here we can say the limit is the value of the function fx when the input x is approaching to 4. So understand the question here. Once again, understand it. Repeat the video and understand what I said. Now here coming to the next part. What is the next part? Here I have limit x approach to 0 or x tends to 0. What does it mean? It means x is coming closer and closer to 0. But there are two ways x will approach to the 0. I will draw here the line. This is here 0 and it is 1, it is 2, it's -1, it is -2. This is simply a number line. You can say here 0. There are two ways. We can approach 0 from this side and we can approach to the 0 from this side. This is the right side and this is left side. So what I can say to approaching the 0 we have the two ways, that's left side and the right side. From left side we can approach the 0, from right side we can approach the 0. When I am approaching from the left side, I can write limit x tending to 0 minus. Above I have to write the minus notation. And here when I am approaching from right side, then x is tending to 0 plus. So what does this mean? X is tending to 0, limit x is tending to 0 minus. That means x is approaching to the 0 from left side. This is the left side. X is approaching to the 0. This is right side. This is called a left hand limit. This is called a right hand limit. I think this much you understood now. Left hand limit and right hand limit. Look at this example. Fx equals x plus 3. If x equal to 3, then the value of the function is, in place of x I should put 3. 3 plus 3, that is 6. Now I will give it a limit. Limit x tends to 3 f of x, that is limit x tends to 3. What is fx? That is x plus 3. It is asking us tell the value of the function when the input is approaching to 3. Tell the value of the function fx when the input is approaching to 3. Now you can see, just to explain, to understand, we have the methods to how to do these questions. We have different methods. Here we will understand. I will give you the example. Once again we will take the help of number line. Let this will be the number line, and here I am writing the 1, 2, and here 3, and here 4, here 5. We know the x is approaching to 3, and we know there is left side and the right side. From left side it can approach, from right side you can approach. You can see in the neighborhood of 3 what are the values. I can take here, first I can take here 3.1, that is on the right side. Here I can take 2.9, that's on the left side. The closer value of the 3, that's 3.1, here it is 2.9. Now see here, when I am taking the value of x, 3.1, what is the value of fx? Put the value of x here. In this, the value of x 3.3, so I will get 6.1. When it will come closer, but not exactly the 3, that means it is coming here, that's 3.01. So at that point I will get, at this point, I will get the value of fx 6.01 and another value 3.001. the value of fx I will get 6.001. And see here, now coming to more close, 3.0001. Here I will get 6.0001 because I am substituting this value, the value of the x here in this function. And here now, if I will write 3.00001, I will get here the value of fx 6.00001. Now you can analyze here. As x is 3.1, then it is close to 3. This point is close, then this. This point is close to 3, then this. So it is coming closer to 3. It is approaching to 3. So we can say when x is approaching to 3, but from right side. So I can write as x is approaching to 3 from right side. Fx is approaching to 6. So as x is approaching to 3, fx is from right side. Fx is approaching to 6. Now I will check the left side. When x equals to the closer point here, I have 2.9. So fx I will get here 5.9. Now next point I will take 2.99. Fx I will get 5.99. Why? Because when I am putting the value of x, that's 2.99 here, 3 plus 2.99, I am getting 5.99. So next, if I am taking the point 2.999, I will get the value of fx. Because I am substituting, understand this x, the value of x I am substituting here. So I will get 5.999. From this, if I will write the values, it will come closer to, the above will come closer to 3, the down, this one, fx will come closer to 6. So we can say, as x is approaching to 3, from the left side, the fx is approaching to 6. So I can say here, as x is approaching to 3 from left side, fx is approaching, or we can say fx approaches to 6. From this we analyzed, we realized, we understood here. So understand this very clearly. What does it mean? X is approaching from the right side to 3. The value of the fx is also approached 6. Here you can see x is approaching to 3 from left side, because this is from the left side. Then fx, the value of the fx is approaching to 6. So we can say here, the limit x is tending to 3, x plus 3 equal to 6. So the limit of the function fx is 6. So how we can define the limit? We can say a limit is a value. A limit is a value that a function approaches as the input approaches some value. I can say limit is a value that a function approaches as the input approach to some value. Understand this definition. So limit is what? It is nothing, it's a value. But when? Which value? You can see it is a value. Here the value is 6. So this is the limit. But how is a value that a function approaches? Is a value that a function approaches. It is approaching. How and when it is approaching? As the input approaches to some value. Input is our x. X is approaching to some value, that's 3. So we can see as the x is approaching to 3, fx, that's x plus 3, is approaching to 6. So this 6 is the limit of this function fx. So we can say in general, fx approach to 6 as x approaches to 3. This is the notation of the limit. We can say fx approach to 6 as x is approaching to 3. This is called the limit. Now we have different formulas. We will see the different formulas and we will see the methodology how we will solve the questions. First you will understand the formulas. We have many formulas and directly we will start the exercise now.